In this problem, we need to find the area bounded by two different curves. One is y equal to 3 by mod x and another one is y plus mod of 2 minus x equal to 2. Now, if you look at both the problems, there is a modulus function involved in defining the function. So, before we proceed to identify the geometrical graph of both the functions, first let us express these functions as piecewise defined functions. What is the first graph given? It is y equal to 3 by mod x. Now as mod x changes its character at less than 0 and more than 0, can we define this function as this is minus 3 by x if x is negative, and this is plus 3 by x if x is greater than 0. So what does this curve denote? Y equal to minus 3 by x and y equal to 3 by x. Correct. They are two hyperbolas to the left of y-axis, that is when x is negative, this is x into y equal to minus 3, and similarly when x is positive, it represents a hyperbola x into y equal to 3. So first let us try to identify how does the graph look like. Cartesian system. Then how will be the graph of y equal to minus 3 by x? Yes, as x tends to 0, y would tend to minus infinity, and as at x equal to 0, the value of y would become almost infinity. So this will be a hyperbola lying in the third quadrant. Now similarly, how will be the second portion of the graph? Y equal to plus 3 by x. As x tends to 0 plus, we clearly observe that y becomes infinity. So on the right hand side of origin, that is on the right side of y-axis, this will be a rectangular hyperbola lying only in the first quadrant. Now there is another part of the graph also, y plus modulus of 2 minus x equal to 2. Now how will be the piecewise defined function for this function? Now again, as modulus of 2 minus x changes its character below 2 and more than 2, let's first define this function piecewise. Y is equal to 2 minus of modulus of 2 minus x, and as we know, modulus changes its character at the term inside modulus becomes 0. That means 2 minus x becomes 0. So then this function is x if x value is less than 2, right? As x is less than 2, 2 minus x is positive. Then when the modulus is opened, this becomes 2 minus 2 plus x, that is x. And when x is greater than 2, what will happen to the modulus? The number inside the modulus is negative. So this becomes x minus 2. So we got 2 minus x plus 2, or the function is 4 minus x. So if you observe both the cases, when x is less than 2 or x is more than 2, this graph is a straight line, right? So let us identify at the point 2 on x-axis. Now below 2, from 0 to 2, this is a straight line and the line would pass through 2 comma 2, and after 2, as x is more than 2, the graph becomes 4 minus x, right? So again this line would pass through 2 and it will cut x-axis at 4. So how will be the line? Yes, that would be a line with negative slope. So this is the portion which identifies y equal to x. This is the line which is y equal to 4 minus x. And similarly, as we have seen, this is y equal to minus 3 by x curve, and this is y equal to plus 3 by x curve. Now which area is required for us? The area bounded by these two curves. So can you identify which region is bounded by these two curves? Yes, the region required is this shaded region is required. Now if you observe this shaded region here, up to the point 2, the line y equal to x is above that of the graph of y equal to 3 by x, and on the right side of this line x equal to 2, the line y equal to 4 minus x is binding some area with the curve y equal to 3 by x. Then what is the area required then? So area of the shaded region required is, now this point is having coordinates 2 comma 2, so we need to find the area. So we need the coordinates of these two endpoints. Now how do we get the coordinates of A? A is the point of intersection of the line y equal to x with the curve y equal to 3 by x. So what are the coordinates of A? A gets the coordinates x square equal to 3, or it is root 3 comma root 3. And similarly, B is the point of intersection of y equal to 4 minus x line with the curve y equal to 3 by x. So for this case, how will be the coordinates of B? Clearly the point would be 3, 1. So we know the point coordinates of B, coordinates of A. So we require this total area. Then the first region, that is to the right side of the line x equal to 2, is bounded by between the limits root 3 to 2. Yes, which curve is above? The line that is x minus the lower curve is 3 by x dx plus, how is the region to the right side of the line x equal to 2? It starts from 2 and the region is extended up to B having abscissa 3. Now here in this, the line 4 minus x is above the curve 3 by x, right? So this is x square by 2 minus 3 times ln x. The value of the limits calculated between root 3 to 2 plus the second term's integrals 4x minus x square by 2 minus 3 times ln x, and for this function the limits are from 2 to 3. Now we know every number in this. So how much does the area come up to? It is 4 minus ln 27 by 2 square units, which is the option presented. The A which says 4 minus ln 27 by 2. So the most important thing in finding the areas bounded by graphs is to identify the correct region to which we need to find the area, right?